Okay, so let's do another type of solving where we have something which is quadratic in form. So remember, when we did quadratic in form type polynomials, the degree of the larger is always going to be double the smaller. So what we're going to do is we're going to solve for, one side 0, bring everything over to the left. So b to the 4th plus 18b squared. And let's take away 24b squared, so we can actually do that right away, which gives you negative 6b squared equals 40, or b to the 4th minus 6b squared minus 40 is 0. Okay. So remember, in order to factor this, what we did was we switched the variables as a u. So the u variable is going to equal the smaller one, and then the squared is going to be the bigger one. Once we do that, we plug it back in to get u squared minus 6u minus 40 equals 0. And now we try to factor this right here if we can. So this is like a quadratic in itself. So you're going to try to do the things that you did normally with a quadratic, which means factor or quadratic formula. And always try to factor first. So 10 and 4. So u minus 10, u plus 4 is 0. And once you get it in this factored form, set each of them equal to 0. Now, once you get to this part, it's up to you what you want to do. My preference is to substitute u back in right here. So don't forget, when we did the u substitution, we had to take the u variable and replace it with the b squareds because our original equation was in b's. So let's go ahead and switch that back. So we get b squared minus 10 is 0, or b squared plus 4 is 0. So b squared minus 10, and then b squared plus 4. Solve. B squared is equal to 10, and then use the square root property. So b is plus or minus the square root of 10. And here, b squared is equal to negative 4, or b is equal to I plus or minus I square root of 4, which is plus or minus I times 2. Now for this one, you want to write it as plus or minus 2i. The I goes at the back of the number. So polynomials, the degree of the polynomial, which is degree 4, has 4 different roots if they're complex. So we have 2 real roots, 2 complex roots for a total of 4. That is the amount that you need. So similarly here, degree 4, so we're going to have 4 different roots. So let's go ahead and in this problem, we're going to u sub again. So u is equal to x squared, u squared is equal to x to the 4th. So we get 2u squared plus 3u minus 5 is 0. Now, you can try to factor this. What you'll find though is that it's not factorable. So not factorable, the other way to solve a quadratic is to use the quadratic formula. So we know that a is equal to 2, b is equal to 3, and c equals negative 5. Now, remember when we were using the quadratic formula, you have to say the input equals the quadratic formula. In this case, we're applying the quadratic formula to this, so the input value is u. So u is equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. This is doing the arithmetic. Negative 3 plus or minus the square root of 9. This is going to be negative 10 plus 40 over 4, and then we get negative 3 plus or minus the square root of 49 over 4. Okay. 49 is 7, So this is negative 3 plus or minus 7 over 4. Now, we haven't done this last step yet over here, which is once we get the u variable, we have to pull it back in to make sure that we have the original variable in the equation. So let me rewrite this part. What we really have here is u is equal to negative 3 plus or minus 7 over 4. Our u variable, though, is x squared. So this is x squared is equal to negative 3 plus or minus 7 over 4. And let's go ahead and split this up. X squared is equal to negative 3 plus 7 over 4, or x squared is equal to negative 3 minus 7 over 4. Okay. Simplify it. X squared, this is 7, 6, 5, 4. This is 4 over 4. And this one is negative 10 over 4, which is negative 5 over 2. Okay. Square root property to finish it off. So if I take the square root of both sides here, x is equal to plus or minus 1. Here though, x squared is equal to negative 5 over 2, square root both sides. These cancel and you're left with x is equal to plus or minus the square root of minus 5 over 2. But again, the square root of minus 5 over 2 gives you an I value. So this is equal to plus or minus I, the square root of 5 over 2. So again, count. There's 4 answers. X equals 1, x equals minus 1, x equals plus I root 5 over 2, and x equals minus I root 5 over 2. So we have 4 solutions, which matches the degree of the polynomial.